We've introduced lists, we've introduced tuples. We said they're ordered sequences of elements. They have different properties, the primary difference being mutable versus immutable. We want to introduce one more kind of data structure, a generalization that has some really nice properties. And that data structure is a dictionary. You've already seen dictionaries in your everyday life. We're going to have a programming language version of it that behaves the same way. And let me show you how that works. Let's start by using an example. Imagine I'm trying to store data about students in a database. So far I could do that just using lists. And I might have a separate list for each kind of data entry. So I might have a list of names, the names of the students in the class. I might have a list of grades for each of the students. I might have a list of the courses that they're taking. What's the grade in? So one grade might be in one class, one grade may be in a different class. I have a separate list for each item. One of the things I'd need is I want each list to be of the same length, of course, because I need to be able to associate all of those pieces together. But the problem I've got is that the association isn't captured in a common place. Here, the information is stored across lists at the same index. So if I want to get information about Anna, I have to go into index 0 and get out the name, the grade, and the course in which she got that grade. If I want to get the similar thing for Katie, I have to go to the third element of each of those lists. So each index refers to information for a different person. And I don't have an easy way to capture that kind of information. As a consequence, if I wanted to write a function to get out information, I'd have to write something like the thing shown here. I've got a function called getGrade. It takes in a student and then the list, a name list, a grade list, and a course list. And what I'd have to do is to say, given that index for that student, I'd have to go and find where that is, and by basically going into the name list and finding the thing associated with student, what spot is Anna at? And having done that, I now know the right index, and I can use that to get the grades list element and the course list element. Or said another way, I have to walk down somehow the first list to find where is that student located, and then use that to go in and find the right spot or the corresponding spot in the other list to get back the grade and the course. Clearly this is messy if I've got a lot of different information I'm trying to track. I've got to maintain multiple lists, I've got to pass them in, and especially I've got to remember to change multiple lists. If I add something to one list, I've got to go make sure I add the right elements in all of the other lists. I could do it, but it's not handy. It's really inconvenient. I'd like another way of being able to do that idea of finding things associated with a particular entry in a structure. And that's where a dictionary is going to come in. What I'd like is to have a way to be able to index to an item of interest directly. And it might not always be an integer, it might be something else. And I'd like to be able to use it using one data structure and not separate lists. So if you think about it, what's a list? It's a sequence of elements where the index is a set of integers starting at 0. And associated with each indice, I have a different element. A dictionary is going to be different. It's again going to be a collection of things, but now I'm going to customize how I index to it. Rather than saying, giving me the 0th element, I'm going to say, give me the element associated with this key. And so we're going to call the indices keys, and we're going to use them as labels that tell me where to find the element inside of the dictionary. So it won't have this nice linear structure I had with a list. It will have a structure to it, but it's going to give me a lot more power in terms of how I retrieve elements out of the dictionary. And I say dictionary because it behaves much like it would in a dictionary of words. I can look up a word and retrieve from that dictionary all the information associated with that word, not having to know that the word factorial is associated with entry 2745 inside of the dictionary. I simply look up factorial and find the entry associated with it. So we can build that in Python. And here's the way we do it. First of all, a Python dictionary stores pairs of data together, a key and a value, the key telling me the thing to look up. I'm going to create it initially with an empty dictionary. And you can see we're using the same basic type of structure. I've now used curly braces or brackets, if you like, in order to represent a dictionary, as opposed to parentheses or square brackets. An empty dictionary starts off with just these curly braces, and then I could create a dictionary of grades. I could give Anna the grade B, I could give John the grade A plus, Denise an A, and Katie an A. And I'm going to index into the dictionary by the key element of the entry inside of a dictionary. So each one of these is association or a pairing of a key and a value. And that's going to allow me now to build arbitrary structures very nicely. So now I'm going to build up this dictionary. There it is. I happen to have stored them in that order. One of the things I'm going to say about dictionaries is I don't rely on the order. They're not going to be in any particular order other than how I happen to put them into the dictionary. And there's an example dictionary of my dictionary. Okay, what could I do with that? Well, given I've got a little grades dictionary, I'm going to be able to look up things in the dictionary. It's going to be similar to indexing into a list, but I'm going to use it based on the key. So, for example, I've got an example of grades over here. I'm going to load it into my environment. Grades, I could print out. It's just an arbitrary collection. But I can now say I'd like to get the grade associated with John. Now, in a list, I would have needed to know what's the index at which John is stored. I can only index into a list based on an integer. But with grades, as a dictionary, I can say, give me back the value associated with that key. And there it is. If I want to get the grades associated with Sylvan, I can type that in. Sorry, I'm going to type grades properly here, and I can type in Sylvan. And it complains, as it should, because there is no key in the dictionary for Sylvan. There's no association of Sylvan with a value. But now the retrieval, the lookup, is simply give me the key, I'll find that entry in the dictionary, return the value. Sounds really good. So what are some of the operations I could do on a dictionary? Just as we had with lists, we're going to have operations on dictionaries. I could add an entry for Sylvan. So I could say into the dictionary grades for Sylvan, add in an entry. Sylvan's doing well in this class. There it is. And as a consequence, if I now say, what is the value associated with Sylvan? It's going to give me back that value. I can add an entry. It's mutable. I can change things inside the dictionary. And I've in fact just made that change to the dictionary. I can test to see if a key is in the dictionary. And literally I do that by simply invoking, for example, is John in grades? He is. Is Daniel in grades? He is not. Python is automatically walking through that structure to see, is that key in the collection of keys associated with this dictionary? We'll worry later on about exactly how he does it, but the nice thing from a programming perspective is I can test very simply to see if a key is in a dictionary. I can remove an entry. As we've done with other things, del for delete will remove an entry. So if I give del, say I want to remove the entry for Anna, in grades, I can do that. If I look at grades, Anna's gone. And in fact, what I just did was change that dictionary. I can add entries, I can test about entries, I can delete an entry. Here are a couple of other things I can do. I can actually get out the set of keys. And so let me go back to grades. I've got grades. And I can say keys, which is a method, and since it's a method, I need to type an open and close paren to say call the method. And it gives me back an iterable. Again, I can think of that like a list or a tuple. It's not quite because it doesn't generate them. It's going to give me a way to find them when I want them, but it's going to act as if I got back that collection of pieces inside of a structure. And similarly, I could get the values out. Grades values will give me back an iterable of the values associated with that structure. And if you're wondering why what I typed on my computer is a little different than what you see on the slide, it's because I did not reload the grades in. I'm using the version of grades that's here. But the behavior is exactly what I want you to see. I get back things so that I could then iterate over. Like I could walk down all the collections of keys, or I could walk down all the collections of values doing something to them. One of the things to notice about both of these is I cannot guarantee that there's a particular order to them. So it's not like the traditional dictionary that you get everything in lexicographic order. It's going to depend on how I put them in there. I just simply need to know that I want to do something with the dictionary and not rely on the order in which things are returned. What else can I say about dictionaries? A couple of things. The values that go into the dictionary can be anything. It could be any type. It could be immutable types like ints or strings. It could be mutable things like lists. It could be functions. It could be absolutely anything can be used as a value. They could also be duplicates. That is, I could put the same value to be associated with different keys. As we also can see here, dictionary values could be lists. I could even have dictionary values be other dictionaries. It can be anything your heart desires. Keys have a little bit more constraint on them. The first one is they need to be unique. Well, that makes sense. If I'm going to look up something in the dictionary, I can't have multiple keys or the same key in different places in the dictionary. It has to be unique, a unique entry. The second key point is that the key must be of an immutable type. So that means an int, a float, a string, a tuple, a bool. Actually, I need something a little stronger, which we're going to come back to later on in the term. They need to be what we call hashable, but right now think of it as immutable because basically everything we're going to deal with has that property. I need to be really careful if I'm going to use a float type as a key, because if the float has an accuracy issue, I may not find the thing I wanted to associate with it. The reason they need to be immutable is I can't store something in the dictionary under one key and then change the key and expect to be able to find it still in the dictionary. It just doesn't make any sense. As I've already said, and I'll remind you, there is no order to either the keys or the values. And so I've given you an example of a dictionary here where one index, one key is an int, another key is a tuple, a third key is a string. How they're ordered in the dictionary, I don't care, but I can have all of those in one dictionary and retrieve from them appropriately. So just to compare the two pieces, differences between a list and a dictionary. A list is an ordered sequence of elements. And in fact, I index it by using an integer index because, in fact, I know it's ordered. A dictionary is simply a collection of entries. I'm going to match keys to values. There's no particular order to them. And I can look up one item by simply using that index to try, or that key to try and pull out the piece that I want here. So in this case, I look up elements by an integer index. In this case, I look up elements by whatever the key is, which could itself be some arbitrary expression. Indices and lists have an order, no order with dictionaries. And the index has to be an integer with the list. The key can be any immutable type. So you can see that dictionaries have a lot more capability in terms of what we can store inside of them. And we're going to look at an example to see how you can use dictionaries and iterate over dictionaries to do interesting things.